Look over to the sideboard here. Algebra 1 on the 12th of September. SWBA. What's SWBA stand for?
Students will be able to.
Students will be able to, the T, solve equations by multiplication and division. 2.3. Very similar to 2.2, except for instead of addition and subtraction, we're doing multiplication and division. Yes, Levi?
We didn't finish 4 and 5 on the.
Oh, you are right. We didn't finish 4 and 5 on the other one. Okay, maybe we should real quick. Yes.
He's trying to be crit.
Let's finish 4 and 5.
I'm trying to say something. It's all the way around.
Let's finish 4 and 5 real quick over here.
Oh, we're just gonna grab the answer.
No, I gotta work it out.
I would rather
with the answers.
Okay.
I'm good with both.
I go to both. Mr. Carlson, nice to meet you.
I do say that.
You said, oh! I'm still trying to learn voices.
My voice sounds like a guy.
Do you know my voice from a mile away? Yes, anybody does.
Do you know my voice?
Because it's so high.
You don't talk so much, it's easy.
Okay.
Write an equation for the problem and solve the problem on number 4 of section 2.2, finishing up section 2.2, okay? So, write an equation for the problem and solve the equation. 14 more than a number is equal to 27. 14 more than a number is equal to 27. I want y'all to write down the equation for this. So go and write down the equation for this one, okay? 14 more than a number is equal to 27.
Trying to be crit.
What?
I think I got it right.
Hi, Mr. Carlson. How are you today?
Okay, hey, who wants to share what they got, what they wrote? Rick.
X plus 14 equals 27.
Awesome, x plus 14 equals 27, because you also have 14 plus x?
Yeah.
Sure, okay. As long as you have some variable plus 14 in either order, it equals 27. We're Gucci, okay? Question on that.
Oh.
How do we solve this?
Subtract 14.
Subtract 14 because we're adding. 14 minus itself is 0. We're just left with x equals. What's 27 minus 14? 13. Easy dub, okay?
Easy collapse.
Okay. Still like collapse, okay? Number 5. The Washington Monument in Washington, D.C. was built in 2 phases. Hey, what's the Washington Monument?
The monument at Washington.
The monument in Washington, okay, it's in D.C. What does it look like, Matthew? Yeah, it's like a big kind of like, it's like a needle looking thing. It's a giant like pointy thing, okay? It's white, it's really tall. Yes, Ray?
Do you know a fun fact about it real quick?
Sure.
So someone tried to put an eye at the top, like when they were constructing it, but then they got like stopped like midway.
An eye?
On the like John
On the point?
on the flag, like painted it up. No, they like carved it in, and there's still a little bit left.
How would you know that? Why do you know that?
Because I used to be like a conspiracy.
Really?
6th grade.
Presley's in love with
I know. We had a whole conversation about aliens.
Yeah, we argued about it.
Oh, yeah, I remember that.
Okay, the Washington Monument in Washington, D.C. was built in 2 phases, okay? That means part of it was built, then it was left, and then part of it was, and then it was finished later, okay? During the first phase, the monument was built to a height of 152 feet. During the second phase, additional construction resulted in the final height of 555 feet. How much of the monument was added during the second construction phase? Write an equation to solve the problem. Okay, hey, word problem, right? We often say we don't like word problems. We see them, we're like, it's scary, okay? Here's the thing about word problems. Here's what makes them less scary, is if we learn how to pick out the important information, okay? There's a lot of information in here that we don't actually need to know. It won't help us solve the problem, okay? That's how it is in every word problem. There's information you don't really need, okay? So it's important for us to pick out what we actually need, okay? So raise your hand if you feel like you know a key piece of information that we need from this word problem. Raise your hand if you feel like you know a key piece of information you need from this word problem. Chase.
You need the
We need 152 feet, okay? And I would say additionally, with that 152 when was that? When did that come in? The first phase, okay? So that might be important to say the first phase was built to 152 feet. So I think that's probably good to know, okay? So that's a number, probably a good idea to underline our numbers. Raise your hand if you have another key piece of information you think we might want. Levi. 555 feet. And hey, when was this height? The final height, okay? So it might be good to know that's the final height of 555, okay? That might be good to know, okay? What's another thing that we might know? Another thing that might be good to underline.
Cold.
Say that louder, Levi.
How much of the volume was added during the second?
How much was added? How much was added? Is that what we're trying to find? Yeah. Okay. How much was added during the second phase? Okay. So we don't know that. So what can we call that if we don't know that?
Question.
Okay. Question. We
Oh,
can call it
unknown value.
unknown value.
Variable.
A variable. What kind of variable do we want to use this time?
X.
X. Cool. Okay. Call that X. The second phase. How much was added? Okay. So who thinks they might have an equation we can do, because it tells us that we need to write an equation, okay? Who thinks they might have an equation that we can use from all of this information we underlined? Dylan?
Oh wait. Could have. Thanks. You could do like.
Okay. Zach?
Do 555 minus 152.
Okay. We could think of it that way, but I wanted to try and approach it a different way. Okay, that would be correct. I wanted to try and approach it a different way. Okay. Matthew?
152 minus x equals 155.
Not quite 152. Something x equals 100 or equals 555. What would I change there, Levi? Plus. Okay. And how do we know it's plus?
You're adding on to the 100.
We're adding on. During the second phase, additional construction. How much was added, okay? So we need to have that addition there, okay? We need to have that addition there. But we do, notice we did what number did we put first? 152. That's what happened during the first phase. What number did we put second? X. That's what happened during the second phase. What did we put at the end? Oh, the final height? Okay, so we put that at the end. So the order for this equation was actually told to us in our paragraph. So if we're able to pick that out, that makes this word problem a lot less scary. Now, is this equation something that we can solve?
Yeah.
Yeah, we know how to do that. Okay, so what would we do? Subtract 152 from both sides, okay? And hey, 152 minus itself is 0. We're left with x equals 555 and 152. Okay, so what's 5 minus 2? 5 minus 5. 5 minus 1. 4. What's our label here? Feet. Don't forget when we have labels, we need them, okay? We're not talking about 403 miles or 403 ostriches, okay? We're talking about 403 feet, okay?
Yeah.
Questions on that? Okay. Now we'll go on to 2.3. What are we betting? Okay. Solve equations by using multiplication and division. Okay, so we're going to start with multiplication, okay? So hey, just like we had the addition property of equality and the subtraction property of equality, saying we can add or subtract the same thing to both sides of an equation, and it's still true. We have the same thing with multiplication. If an equation is true and each side is multiplied by the same number, the resulting equation is true, okay? So for example, in these symbols, for any numbers A, B, and C, if A is already equal to B, two things are already equal, then if we take the first one times C, and we take the second one times the same C, that will also be true. If we take the second one times the same C, that will also be true. A number example could be like 2 is equal to 2. Is that true? Okay, we start off with a true equation. Okay, what do you want to multiply 2 by? 3. Okay, cool. 2 times 3 on the left side, and we do it to the right side as well. Okay, and what is 2 times 3? What's 2 times 3 over here? Oh, it's still the same, okay? So did we end up getting a true equation still? Yeah, so we see that in numbers, okay? That, hey, if we have the same thing, if they're equal, and we multiply it at both sides, we're still equal. As long as we're working for the same thing. Would it have worked if I multiplied the left side by 3, but the right side by 4? Would it have worked if I multiplied the left side by 3,
No.
and the right side by 4? No.
You have to do the same thing to both
Okay,
sides.
we have to do the same thing to both sides, okay? So we said addition and subtraction, they undo each other, okay? The mathematical word we use is they're called inverse operations. They're opposites of each other, okay? What's multiplication undo? No, that's division, okay? So we're gonna look to multiply to solve when we're dividing, okay, by a variable. Or when the variable's being divided. So here, might be hard to see, but this is S over over
12.
that is 12, not 1.2, okay? 12 is equal to 3. S over 12 is equal to 3. So our variable is being divided by 12. So how do we undo division? Multiply. We're going to multiply this side by 12, and then we also have to do what to the right side? Multiply by 12 as well, okay? Now, hey, a lot of times on this left side of the equation, we say, hey, dealing with a fraction, it's easiest for us to think of this as a 12 over what number? 1. You don't have to write that over 1, but a lot of times it's easier for us to think about it that way, okay? So what can this 12 and this 12 do?
Multiply.
Okay, they can cross reduce, okay? 12 goes into 12 how many times?
1.
And 12 goes into 12 how many times?
One.
Once. What's 1 times S?
S.
S. What's 1 times 1?
1.
Do we even have to write that it's over 1?
No, just S.
No, we can just write
Oh,
S.
so cancel it out.
They undo each other. I don't like the word cancel.
Why?
Because it's mathematically inaccurate. Cancel implies that it goes to 0, but it doesn't. It goes to 1.
Okay.
Dang.
3 times 12 is
Sorry, what?
36.
36.
36.
I don't know my 6 is very much on
Okay. And it says check our solution. So how would we check this?
Plug it in.
36 into S.
Plug it in. Okay. So 36 in for S. 36 divided by 12 equals. You guys remember that deflection thing? Equals. Okay. 3. What is 36 divided by 12? 3 does 3 equal 3? Yep. We checked it and it worked out just fine. Okay. Question on that first one? So hey, I want you guys to try number 2 on your own, okay? So this is 1.8 equals W over 2. 1.8 equals W over 2, okay? When you have it, or you think you have it, or you have questions, raise your hand. When you have it, think you have it, or have questions, raise your hand. Exactly, or help them out. Okay, so I have next one? Yeah. Should. We're going to talk about this one up here. Okay, so we know we need to multiply by 2 to undo that division. Okay, so on this right side, you can think of this as a 2 over 1. And what happens with these two? They divide out, right? They both become 1. They don't become 0, they become 1, okay? So we're left with just W on the right-hand side, okay? Because W times 1 is W, 1 times 1 is 1. Anything over 1 is itself. Okay. 2 times 1.8, if we don't know that, write this down over here. When we multiply, we do not have to line up our decimals. We you multiply, you do not have to line up the decimals. Okay. 2 times 8 is 16. 2 times 1 is 2, plus 1 is 3. How many numbers are behind the decimal?
1.
1, so we put 1 number behind the decimal. Questions on that?
That's what I got. Simple multiplication error. You're
Okay.
home.
We can check our solution as well by doing 1.8 equals 3.6 divided by 2. Okay? If you don't know what 3.6 divided by 2 is at the top of our head, we can write that down. Remember, when we divide and the decimals inside the doghouse, inside that division symbol, you carry it right above there. 2 goes into 3 once. 2 times 1 is 2. Subtract, you get 1. Drop the 6 down. 2 goes into 16. 8 times, and it is 16. And so it ends up being 1.8. So yes, this does check out. Questions on how I did that checking? I did division quickly. Question on how I did the checking. Okay, any questions on number 2 at all? Okay, I want you guys to try number 3 on your own. Okay, number 3 on your own. Okay, when you have it, think you have it, or have questions, I want you to raise your hand. Have it, think you have it, or have questions, I want you to raise your hand. We're good. And when you're done, think you're done, or have questions, raise your hand.
Hey, that's your test. That makes sense. You should go to. You smell like cornflakes.
I had it hanging up there and it fell. So I've had it here since it's that. Oh. this one up here. We're gonna talk about this one up here, okay? So our first step is to do what?
Two
Multiply by 3, okay? We ignore the fact that there's a fraction over here for a moment. We say, okay, n's being divided, so we multiply by 3, okay? And we can think of this as a 3 over 1, and we multiply the other side by 3, okay? And hey, do we have a fraction on this right side now too? So we can think of this as a 3 over 1. That will help us out, okay, a lot mentally, okay? So over on the left side, what happens with this 3 and this 3? Since they're diagonal and they're multiplying, they cross, not multiply, they cross, reduce, cross, simplify, or cross, divide, okay? 3 becomes a 1, and 3 becomes a 1. So we're left with what on the left side? Just n, because everything else became 1s. Equals negative 2 times 3 is
6.
negative 6. 5 times 1 is
5.
5. Can we reduce this?
No.
No, I'm okay with it being an improper fraction, okay?
I was overthinking.
I did it right.
Hey, reminder, does it matter whether we put the negative on the top, the bottom, or out in front? Did we talk about this in here? Okay, I thought maybe we hadn't, okay? Whether we put the negative on the top, the bottom, or out in front, regardless, it's the same. It's the same no matter what, okay? As long as there's only one negative, somewhere on this, it's the exact same, okay? So whether or not you put the negative top, bottom, or if you can put it out in front, it's the same thing, okay? We're perfectly fine with it being anywhere on that. Okay, as long as it's somewhere on the fraction, it's okay. What is not the same is if you have something like this. That is not the same. Because a negative divided by a negative, because a fraction is really a division problem that we're just too lazy to finish, okay? It's a joke I heard. Negative divided by negative is what kind of number?
Positive.
Positive. So it's the same thing as positive 6 over 5. So these two are the same, and these 3 are the same. Does that make sense?
Yes.
Sure. Okay. Continue on. Okay. So if there is a fraction in front of the variable, we will multiply by the reciprocal to isolate that. Actually, here's what we're going to do. I'm going to skip that part for a moment. We're going to come back to that in a moment here. Before we do that, we're going to go to the next page. We're going to go to the next page. We're going to come back to that though. We're going to look at solving using division first, okay? We're going to look at solving using division first, okay? So this is going to be the same type of thing. We have the division property of equality. We've had an addition, a subtraction, and multiplication. Division property of equality, if an equation is true and each side is divided by the same non-zero number, the resulting equation is true. Why do we say divided by a non-zero number? Because we don't divide by 0, right? That breaks math. Undefined. Can't do it. Okay? For any numbers a, b, and c, if a equals b, then a divided by c is equal to b divided by c, as long as c does not equal 0. In numbers, okay, we could do, let's say we started with 8. Let's say we started with number 8, okay? We have 8 equals 8. Let's say we divide 8 by, let's divide it by 2. On both sides. Okay, what is 8 divided by 2 on the left? 4. What about on the right side? 4. Hey, did we get the same thing? Yeah, would it have been the same thing if we divided by a different number on both sides? By a different number on the left from the right. No, like if I divided by 2 on the left but 4 on the right, it wouldn't be the same, okay? Or if I just divided one number by 2 but not the other side, it wouldn't be the same. We do both by the same number, okay? We can choose any number, we have to do both by the same, okay? So let's work on this one, okay? Hey, we said multiplication and division undo each other, okay? So here, what's happening with 11 and w if we have them pushed up together? They're getting multiplied. How do we undo multiplication? Division. What are we going to divide by here? 11. You divide by that exact same number. If you're to the left side, what do we do to the right? Divide it, okay? Hey, what's 11w divided by 11? What happens with this 11 and 11? They become 1, and we're just left with 1 times w, which is w, okay? Remember, anything divided by itself is 1. 5 divided by 5 is 1. W divided by w is 1. 11 divided by 11 is 1, okay? Now 143 divided by 11. We probably don't know that off the top of our head. How many times does 11 go into 1? Oh, it doesn't. How many times does 11 go into 14? Once. 11 times 1 is 11, and 14 minus 11 is 3. Drop this 3 down. How many times does 11 go into 33? 3. And that does end up becoming 33. So we have no remainder. So it goes into 143 13 times. Remember, positive divided by positive is still a positive.
Yay.
Questions on that? Okay. How would we check our work if we were to
Plug in.
plug it in and then multiply, right? We would plug it in. Okay. 11 times 13, right in parentheses, because that's what that would mean is to multiply now, equals 143, okay? And we practice that multiplication, 11 times 13. We say, okay, 3 times 1 is 3, 3 times 1 is still 3. Add a 0 in, 1 times 1 is 1, 1 times 1 is 1. Add them up, 3 plus 0 is 3, 3 plus 1 is 4, 1 is 1, 143. It does in fact check out. Questions on that? Okay. I want you guys to try the second one on your own. You guys try the second one on your own. Okay. When you're done, when you think you're done, or have a question, raise your hand. Very good. Check. Yeah. Very good. Check. What's your hands on these?
Because positive times negative equals negative.
Oh, yeah.
Should. Negative 8. Should. Negative 8. Good for you.
Give me my playback. It is grass. Grass color. Give me my playback. Can I put you on?
You always do anyway.
Where are you?
Oh. Alright, let's talk about this one up here. So what do we do? Negative 8 is multiplying with x, and what do we do? Divide by negative 8. Okay, divide by negative 8. Okay, so we end up getting just x is equal to what?
12, negative 12.
Negative 12, okay? And if we got it off the top of our head, that's okay. 96 divided by 8. 8 goes into 9 once. 8 times 1 is 8. 9 minus 8 is 1. Drop the 6. 8 goes into 16 twice and is 16. We have no remainder. Can we check our work as well?
Yeah.
By plugging it back in? Yes, we could. Okay. Let's go ahead and try number 3 on our own. Try number 3 on our own, okay? If you have it, think you have it, or have questions, raise your hand. If you have it, think you have it, or have questions, raise your hand.
No. I would love to help.
Yes. Is this
Yeah.
correct? Eli?
Yeah.
Can you please continue?
Sure.
Chase, what do you want? You're good too. I used to work at Walmart, and we'd always joke like,
It's two negatives.
you really want like, hey, did you check out? Are they waking up?
Did you check?
See, no.
Oh.
Yeah, basically the same you get. Cheated reasons probably.
Also, we got to cheat on our name.
Happy
Who's
birthday.
eating pumpkins?
We got to
Did
cheat
you
on
know
our
that's
name.
my saying? Like,
I
I
did
did
the
the
joke
joke
because
because
you
birthday.
did
Yeah, I do. Serious or?
Yeah.
No.
Did you get new
Yeah, I
fire
do.
fart things? Because they used to, ow!
Right
They used to knock
under-
that out.
Right.
You don't want it.
I didn't get my leg on the middle thing.
Have you ever seen that one episode of SpongeBob?
Yeah, good job.
Where he's like, we do, we have claustrophobic, and the Patrick's like, it's claustrophobic. And SpongeBob's like, "Is it for you?"
I should at least know
Oh,
what
oh,
the rest of
oh.
the matters.
Devon.
Oh my gosh,
You're in sixth grade, you know what, like, you know what, like, you're.
Yeah, I said I squeezed it.
He's like,
that's the claustrophobic guy started freaking out.
Have
you followed the Matt Me page
No, I went into the thing, so me right.
It's so funny.
It's so funny.
I don't have it.
You don't? We'll get it and just follow that.
Yeah.
It's really
Like,
fun.
I don't know who made it.
Freaking out.
We were in like.
I do love games.
I don't know.
Sixth grade, though.
Your huge
What do you have?
resolutions were like, hit 'em.
Just Facebook.
Yeah, we kept hitting
I haven't used my
don't
Twitter in like 5 years.
Me neither. I don't
So me and Levi like.
That's my ass.
I just hope no adults ever like find my stuff because like not that I post anything bad, I just like post random things that
Look how
pop in
many
my head. Like
Snapchats I've written. Oh my.
like one time I was like, I want Swedish fish. Like why am I posting
Oh,
that? I don't know, but it's just like stupid.
That sounds like the ones I posted back in middle school.
From right now.
Hey, negative 0.42 equals negative 3 times s. We're multiplying by negative 3 times s, so what do we, how do we get rid of that? Divide by negative 3 to both sides, okay? On the right side, negative 3 divided by negative 3 goes to 1. We just have s equals this. Okay, let's figure out what this is. So, in our doghouse, you heard it called out before in our division, you have the 0.42 inside and the 3 on the outside, okay? What do we do with that decimal? Put it up to the top, okay? If it was on the outside, you have to move it. But when it's inside, we just put it up right above where it's at. Does 3 go into 0? No. Does 3 go into 4?
Yes.
1. 3 times 1 is 3. Drop the 2. How many times is 3 go into 12? 4. And it is 12. So our answer is 0.14, or just 0.14. Hey, wait, what about our sign? Negative divided by negative is a?
Positive.
Positive.
Same size, positive.
Same sign, that,
Okay.
different signs, subtract.
Same sign, different signs, different keep the bar.
That sounds like that class.
Different signs,
It's
negative
sounds-
2. It does that in the back, does it not? It's like 2.
Okay. Write an equation for the problem below, then solve the equation. Negative 14 times the number equals 224. Negative 14 times the number equals 224. I want you guys to write down the equation real quick. Write down that equation real quick, okay? When I say Gucci, you say gay. Gucci.
Yay.
Gucci.
Yay.
That would go way better than I thought it would. You guys are awesome. You guys are like hands down my favorite first hour algebra class.
AWE.
We're the only first hour.
I actually felt awesome. I just tried.
You should say we're your favorite hour of all.
I was
He's like, it's not true.
I don't have a
Yes,
favorite
you do.
class. I super don't.
I have a favorite teacher. How do you not have a favorite class?
Everyone else.
Who's your favorite
Who's
teacher?
your favorite
Mr. Crosswell, obviously.
You only say
that 'cause you're in the
I know, I
Oh, no.
swear, I don't like a lot of the teachers.
I'm not even my own favorite teacher.
Oh, you know who's my least
I
favorite teacher?
like
Mr.
Mr.
Howard.
Howard.
No, Miss
I
Urbauer.
Yo, Mr. Howard's one kid.
I
Urbauer's okay. She freaks out.
Mrs. Urbauer is a sweetheart, though.
I
What's
hate
her. show her this video later.
What'd she
Dude,
do
the other
to you?
day, remember yesterday she started saying stuff to me because I was
Oh,
talking to
yeah,
Kate.
I
And
remember
I
that.
threw attitude to her, and then she started yelling at me, and I was like, oopsie.
Don't throw shit.
Serenity, what do you have?
That was why.
I got my phone. You got games on your
We almost agree. What's our first word though?
Negative.
Negative 14x equals 224. Do we have to have x? Do we have it a different variable? We can have any variable, okay? Now I want you guys to go ahead and solve it. Okay, so go ahead and solve it real quick.
Are we?
Solving this one.
Oh my gosh!
I know, Mr. Dawson makes me.
She did that earlier, we didn't catch it. She did something like,
I know, I
said,
heard her.
"Listen, I'm gonna-"
She goes, I'm cold.
Yeah, she said that, and I missed it.
I am.
Wait, so if I say I am something,
Hey,
does that count?
Yes, because you're still introducing.
Just say Danny.
She just said
Danny is.
she just
blah,
said
blah,
she is
you know?
something.
That's why you broke. That's true, that's true. But she's asking me a hypothetical, so I'm not gonna ping her on it.
Yeah, but still.
When I was in the third grade, I
So we
did
divide by negative 14.
Yo.
I told you no. X equals what? What do we get? So we want to be brave. Okay, Cheyenne? Not quite, because we're dividing. We're dividing. Okay, Nataria.
I said negative 16.
Does anyone agree with Nataria?
Yeah.
Good, good. I would say that's right.
I would say I have something to say, but I know that it would not have anything to do with class.
Okay, so we're not going to do that.
Exactly. That's
Questions
why I
on this
put
one?
myself back.
Go back to the previous page, that section we skipped over. We're going to go back to that, okay? Okay. So, if there is a fraction in front of the variable, we'll multiply by the reciprocal to isolate the variable. You guys remember reciprocal, what that means? Reciprocal, it's a flip version of the fraction, right? Okay. Let's look at this. Let's take a close look at this as why we do this, okay? I want to take a closer look at why we do this. 3/5 and k. What operation are 3/5 and k doing? Multiplying. How do we undo multiplication? We just said it was division, okay? So you would divide by whatever number is there, right? Like on the previous problem, when you had like 11k, you divided by 11, right? When you have 3/5 times k, you're gonna divide by 3/5 on both sides. You divide by 3/5 on both sides. Now, hey, the thing is though, is we don't like dividing by fractions, do we?
No,
What do we
we
say
don't.
we do instead of dividing? We
Make it 3.5 or 3.5.
no,
Make it a decimal.
no, we flip it. We make the reciprocal. And what operation do we change it to? We change it to multiplication, okay? So instead of dividing by a fraction, we multiply by the reciprocal, okay? We're going to multiply both sides by the reciprocal. Okay, so instead of dividing both sides by 3/5, we're going to say, okay, it's the same thing to multiply by the reciprocal. Okay? Let me show you guys why real quick, why it's the same thing. Off to the side, you don't have to write this down, okay? If I have 11k is equal to, what did we have earlier with that? We had 11k equals, 11w equals 143. So if I do that equal to 143, okay, like the problem we had earlier, we divided by 11, right? To solve that. If we multiply by 1 over 11, we multiply by the reciprocal, like we're doing here, multiplying by the reciprocal, multiply by the reciprocal of 11, 1 over 11 on both sides, okay? Let's look at this. It's like an 11 over 1. What happens to this 11 and this 11? They simplify, cross reduce, and we're left with k. 143 and 1. Well, could we actually just multiply this together and then divide?
Yeah.
We could call that 143 divided by 11. And hey, are we going to get to the same spot we would have? Yeah. So you can always think about dividing as we're multiplying by the reciprocal. You can think about that for any number. We just don't normally do it unless it's a fraction. Because does it really help us here to think about it as a reciprocal? Not really, okay? It just would be easier for us to think of it as normal division like we did. Here though, with the fraction, it makes it a lot easier to think of it as a reciprocal. So we do it there. You can really do it any time, but that's why we're multiplying by the reciprocal now. And hey, what happens with this 5 and this 5? Cross reduce, they both become 1. What happens to this 3 and this 3? Cross reduce, they become 1. Hey, what are we left with on this left side? Just that K. Okay? And hey, here, calling it R, okay? We can think of this as a 6 over what, since we have a fraction? 1. Okay? Can we see any cross reducing here to make our life easier?
No, senor.
Yes.
Wait,
Six
yeah,
to two.
yeah.
What
3,
goes,
6.
3 and 6, what goes into both of those?
3.
It goes into 6 how many times?
2.
And how many times is 3?
1.
What's 2 times 5? 10. 1 times 1 is 1. K equals 10.
What? Wait, how'd you get K?
I literally worked
How'd
on
you get K equals 10?
Oh my god.
So once were you tracking with us here?
Hmm?
Were you tracking with us here?
Yeah.
Okay. So we do 2 times 5.
Yeah, that's
10. Okay, what's 1 times 1?
wait, are you?
I don't understand anything you just did.
Okay.
Yeah, you just like. Yeah, can you do another problem?
Okay. Do I need to back up?
I got it.
What?
Press later.
Okay. Let me back up a moment, guys. Okay. So attention back up here, please. Attention back up here. Okay. Let's make sure everyone's engaged real quick. Okay. Hey, so 3/5 times K. Okay. We walk through what I did. 3/5 times K is equal to 6. We undo multiplication with division. We divide by the same number, 3/5. We don't like dividing by fractions. It's weird. So we say it's the same thing as multiplying by the reciprocal. Just like we did in this other example. Okay, did this other example make sense to all of us or no?
No.
That part didn't make sense to us. Okay, let me
Yeah.
walk through this part. Okay, so I said let's start with the problem we had earlier. 11K is equal to 143. Okay, we had that as 11W earlier. Okay, we divided by 11, correct? Okay, we divided by 11. I said that's the same thing if I multiply by 1 over 11. I said let's multiply by the reciprocal. If it's really just 11, then that's 11 over 1. If we reciprocate or flip, okay, we're multiplying by 1 over 11. Okay, because that we don't like dividing by a fraction, so I'm saying, hey, reciprocating and we multiply is the same thing as dividing. 1 over 11 multiplied on each side. We said, hey, this 11, they reduce. We get K. Just like if we were to divide by 11, we'd get K, just in the same fashion. 143 over 1 times 1 over 11, you can say it's 143 over 11. And that's what we have here, 143 over 11. And both of those ended up becoming 13. Both of those ended up becoming 13. So it ends up being the same thing. Does that make any more sense now or no? Okay, and you're still saying no. What part did I lose you at?
I don't know. This is just all confusing.
Okay. Does it make sense how these numbers are the same?
No.
Okay. Does this part make sense up here? Okay, that's what we did earlier. Was we did like we just divided and then we left it. Then we found out our answer. So 11K equals 143. We would divide and then actually do this division, right? Okay. Over here, same problem. 11K equals 143. We're saying instead of dividing, we can do the same thing but multiply by the reciprocal. Does it make sense that 1 over 11 and 11 over 1 are reciprocals? You're just saying sure. Okay. We can think of any number as being any number over 1, correct? Okay. How do you flip that? What's the flip version? The flip version would be 1 over 11. So they're reciprocals of each other. Does that make sense? Okay. So now they're reciprocals of each other. We can multiply by that reciprocal. I'm going to multiply over here, and I do it to both sides to keep it equal. Okay. And all this is saying is we're saying it'll be the same as dividing. That's what I'm doing to show here. I'm showing it's the same as dividing by a number. It's multiplying by the reciprocal or the flipped version. Does that make sense? Okay. Does this part make sense how 11 and 11 reduce? We just get K.
Yeah.
Okay. Does this part make sense? Okay. 143 is 143 over 1. We do that because we like that better for fractions. And so we multiply straight across. 143 times 1 is 143. 1 times 11 is 11. Okay. And and that ends up being 13, just like it was over here. Okay, does that make more sense? Chase.
For like this, if you have two fractions, you have to do it over.
Reciprocal of each, just on one. All right, we'll talk about that in our next example. Okay. So going back to this example, when we divide by the fraction, we say we multiply by the reciprocal. So we take 3/5 k, multiply by the reciprocal of the fraction, 5/3. If we go to the left side, we also have to do that to the right side. Multiply by 5/3 times 6. Thought of this as 6 over 1. From there, we reduce, okay. Reduce. 2 times 5 is 10. Let's try another example of this and let's see how we think of it, okay?
How'd you get the 2?
How many times does 3 go into 6?
Oh, that makes more sense now. Okay, sure.
Okay, let's try another example up here, okay? Negative 1 over 4 is equal to 2/3 b. What are 2/3 and b doing with each other? Multiplying. How do we undo multiplication? Dividing. Do we like dividing with fractions?
No.
No. So we think of dividing with fractions as multiplying by the reciprocal, whatever you want to call it, okay? So what's the reciprocal of 2 over 3? 3 over 2. So let's multiply by 3 over 2. Just like we multiplied by 5 over 3, okay? If we do it to the right side, we also have to do it to the left side. Multiply by 3 over 2. Okay, make sure we all hear and have this part written. Okay, 3 over 2 times negative 1 over 4. Can we cross reduce the 3 and the 4? No. Can we cross reduce the 2 and the 1? No, not really.
It
Can't
just
reduce
says the
to
same
1.
thing.
It's the same thing. Okay, what's 3 times 1?
3,
What's 2 times 4? 8. And what kind of number do we have?
negative.
Negative, because a positive times a negative is a negative.
Wait, what?
Okay.
Wait, why is it still flipped though?
Wait,
Why
I'm
is this one
confused.
flipped?
Wait, what did you just do?
Okay.
He just multiplied that.
Yeah, I
So-
know, but 3 times 1 is
Okay, so we said
Oh,
here,
alright.
we said here that this is multiplying, right?
Yeah.
So we would need to divide, don't we?
Yeah.
And we divide by that same number, just like here, 3/5 divided by 3/5. But when we divide fractions, we think of it as multiplying by the reciprocal. That's how we divide fractions. We change that division to multiplication, dot, and we flip it. Does that make more sense?
So we keep it flipped the whole time.
So we multiply by the reciprocal. That's what the number you multiply by. So yes.
Oh.
So we multiply it by 3 over 2. Just like earlier, you could multiply a problem by 5 on both sides. We're multiplying both sides by 3 over 2 now. We have the equal sign. What happens to this 3 and this 3? They become 1, they divide out. What happens to this 2 and this 2?
They cancel out.
I don't like that word.
Undo.
Undo, okay, they simplify to 1. We're left with what over here?
Oh,
Just b.
That makes more sense on that.
Now we have our answer.
every time you say K, I think I'm wrong.
But, okay, that makes sense. What if we add a 1?
So,
That's
question on number 2. Question number 2.
No, that was, let's
Okay.
What?
add like the
What?
I was looking for one.
Yes. This is taking a little longer than I thought, but that's okay. It's good practice for us. It's good for us, okay? So 3. Negative 1 3/8 k is equal to 2/3. Hey, wait. This one is a little bit different. We have a mixed number here in front of our fraction instead of just a normal fraction. What can we do with this mixed number?
Undo it, like
Can we make it an improper fraction?
Yeah.
Yeah, we did this earlier today, okay? What's 1 times 8? 8. What's 8 plus 3?
wait, that's a negative. What?
Yes.
So
Yes,
that's 11.
but the whole thing's negative.
Oh,
Okay, the whole thing's negative. So we have to call it a negative 11 over 8k is equal to 2/3. Okay? So this math we did over here was we said, okay, what's negative 1 times 8, or actually not negative 1, just 1 times 8. We kind of left that negative out in front. Okay, kind of think of it this way. I need to write the name. Okay, so inside the parentheses, we thought of it as, okay, what's 1 times 8? 8 plus 3, 11 over 8. And then we add that negative back in. Questions on how we got that? Okay, so we're saying this whole entire number is negative, so our whole entire number needs to end as negative. We're not saying the 1 is negative and the 3 is positive. We're saying that the whole thing's negative. We just put one negative sign there to show that. So we're still saying this whole number is negative. We just put a negative in front to show that. So now, how do we undo this multiplication? Divide. But we don't like dividing by fractions, so what do? We flip it. So what would we multiply by?
8 over negative 11.
8 over negative 11. Okay, we're going to multiply by the reciprocal. Just like we done these previous two problems. We would divide, but we don't like dividing by fractions. So we multiply by the reciprocal. And if we do that to the left side, what do we do to the right? The same thing. Okay, on the left side, what happens with this 8 and this 8? They become what number? 1. They simplify out, they cross reduce. Negative 11 and negative 11, will those cross reduce? Yeah, what do they become? 1. Negative 11 goes into both of
It
those.
becomes K.
And so it's just K equals, and hey, is that what we wanted? Did we want to just get the variable by itself?
Yes.
Yeah, that's why we're doing this method. That's the only reason we chose that number. It's the only reason we chose to do this operation is because we got the variable by itself. Can we cross reduce 8 and 3 here on the right side? No. What about 2 and negative 11?
No.
No. What's 2 times 8?
16.
What's 3 times negative 11?
33.
And it's a negative, right? Does it matter whether we put this negative on the top or the bottom? No. Or out in front, you can do the same thing. So, questions over that? Okay. Yes, you may put those away. I do have a homework assignment, guys. Heads up.
Ivy Wells, Hunter Atkins, DJ Wiseman, Riley Sedlak, Alyssa Fox, and Cadence Hinton. Morgan Doskey, please come to the office after the bell.
All of them?
Yes, it will be all of them, okay? I intended for us to have more work time. That fraction part took a little longer than I anticipated. That's fine. I'm not upset about that at all. I think that was very good, and I think we learned a lot from that, so I think that was fine. Yep. Okay. That's what next time. Hey, I don't have you guys tomorrow. I will see you on Fun Stock Friday at Devil Mania. Okay? See you on Fun Stock Friday at Devil Mania, okay? And I'll see you guys again next Tuesday.
What is today?
Tuesday.
Thursday?
Because we have
Oh,
a-
yeah,
all-
yeah.
Thursday.
Oh, yeah.
Yeah, I'm at that. Okay, so during advisory time, I'm gonna have you just come right away. Okay? Does that make sense? Okay, so don't even go to Mr. Jones. I'll email him to let him know, okay?
Clear.
Thank you, Zach.
Clear.